Well, hello again everybody. Now I know that they say that variety is the spice of life, but today I've got another TV pattern generator for us to have a look at. So that last pattern generator that we actually had a look at was made by Lab Gear in Cambridge. Well, this one is actually made by a company that's actually much more famous for actually producing both radios and televisions, and this is the Cossor company. And actually, as it happens, I'm sure you remember that I actually restored a Cossor radio, a battery set, not very long ago, so this is made by the same company. Now I believe that this particular pattern generator, I think that the date from around the 1950s, and there was quite a lot of these built from what I can tell, but just reading on some of the forums, they aren't particularly loved or favoured, these Cossor pattern generators, so I'm not sure why. Maybe we'll find out when we have a go at getting it up and running. Oh, here she blows. Oh. Well, first signs are it's looking pretty crusty in there. So this looks as though it might have been stored somewhere that's a little bit damp, because everything's covered in white powder, which let's hope that is some kind of let's hope that's just some kind of oxidation. Knowing my luck, it's probably raw asbestos, ground up asbestos, that's probably what it is. Now it looks as though it's actually come off. There's a potentiometer here, and the potentiometer is actually covered in this white stuff, and aluminium does that, doesn't it, when it's been damp. So I think this has actually been stored in some damp place. Oh, I've just spotted some, looks like we've got some across the mains capacitors there, so they're going to explode, aren't they, when we switch this on, so maybe we've got to take them out, because they always go. So this is, because this is a signal generator, you quite often find these across the mains capacitors. Well, this one's probably like the equivalent of a Y-rated capacitor. These capacitors go to ground, so these are there to stop the any EMI leaking out of the mains cable, I would have thought. So on my initial inspection, it looks like everything's there. We've got some valves here, I don't know what these are, probably one of them's something like a rectifier valve, I'm not exactly sure, but it does look like all this white powder that I'm covered in, it all seems to have come off the, I think that's an aluminium can, it could be aluminium, I'm not sure, maybe it's zinc. Yeah, maybe it's zinc plate actually, not aluminium. Well, the zinc has done what it normally does, and it's become a sacrificial, what's to say, sacrificial cathode, is it sacrificial anode? I think it's anode, isn't it? It becomes sacrificial anyway, and the zinc seems to have just turned into powder as it does. So yeah, we might have to replace that, probably still work. Looks like that's some kind of preset potentiometer anyway, because it's just got these short shafts on the back. In fact, there's a few of them, but there's only this one that's got an aluminium can on it. So I've just spied another nice original Cossor valve here, which is a 6N7 GT, which if memory serves me right is just a kind of a general purpose, I think it's a double triode valve, I think that's what they describe these as. And yeah, again, looks in good condition, doesn't look particularly burnt or anything, so let's have him out, because I do like to take valves out when I'm working on a piece of equipment. Got another valve here. So generally when it's got a Y in it, it just tends to mean it's a rectifier valve, so I'd probably have a pound with you that this is some form of rectifier valve, 7Y4. So I've just gone on the National Valve Museum website, which is a great resource for looking up information on valves, and again it's got a picture of my very valve, my 7Y4, and it says it's British made, which of course it is, being Cossor. And it says it's the 7Y4 is a late 1930s American full wave rectifier. Now of course it does say full wave, but I'm sure the way that this will be wired on circuit, it'll actually be wired on a centre tap transformer, so it's actually only contains 2 diodes rather than 4 diodes that you'd find in a traditional bridge rectifier. So as I say, this is probably used in a centre tap transformer configuration. So that one was 6SN7. Now I think I've actually got some data sheets. I've got the manual for this, I've managed to download it, but I do like to try to make a note of the valves as they come out. So you can see here we've got another 3 valves, and these are actually held in place by this piece of plastic, this piece of Bakelite, and it's got a big spring on it, so Can I just lift that off to gain some access? I think we can, yeah, that's off now. And I can see another valve here, another Cossor valve, which is a 6J6, which is a double triode valve. And another interesting thing about a 6J6 is it's actually another American style valve. So it's an American valve which was later made by Cossor. Well, I'm sure you're going to agree this Cossor 6J6, he's a delightful little fella, isn't he? How cute. And this year's award for the crustiest wafer switch goes to the Cossor pattern generator attenuator control. That is seriously crusty. Yum yum yum. Ooh, some lovely filth down here. So on the top side, again, everything's covered in this white powder. And again, what I think this is some zinc that's oxidised, and yeah, it's gone powdery. But the actual components themselves, they don't actually look to be damaged. So I think we'll probably just be able to give this a bit of a clean, and hopefully, fingers crossed, we'll be okay. So interestingly, it looks like our mains transformer. It's almost encapsulated in, well, it feels like some kind of, well, I'm going to say it's some kind of wax, but I think it's actually tar. So hopefully that should have been protected from any moisture. Obviously got a main smoothing capacitor here. Looks as though this should be pretty straightforward to work on. I'm not seeing any problems so far. Everything is very, very accessible, so fingers crossed. I can't see anything burnt out, although we've not had a detailed look yet. So you can see here that somebody's gone ahead and pinned a tail on the old girl, so we've got another of those Eddy Swan connectors. Now I don't know if it'll show up on camera, but the pattern on this Bakelite connector, it's absolutely beautiful, it's lovely. Let me show you. No, it looks like this one is made by Galt Tone, so I don't know who they are. Galt Tone, and it's made in England, 5 amp at 250 volts. Oh, we score red and black wires, red and black, 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 red and black. Lovely. And of course, because this is just a 2-pin connector, we've got no earth wire. Well, my hands are filthy already, so I think before we do any more work on this, I'm going to take this outside and give it a bit of a scrub with the old wife's toothbrush here. In fact, looking at this toothbrush, it is actually in pretty poor condition, which is, yeah, it's not as good for cleaning knobs and valve radios, so I must make her get a new toothbrush. I'll have to remind her of that when she comes in. So we've got a variable capacitor control in here, and it's got a slow motion drive, but it's actually got bearings in it, little roller bearings, so again, while I'm here, let's give them a bit of lube, because we need to keep our balls lubricated, don't we? So judging by the fact that it has got this 2-pin mains plug, I'm going to guess that this thing hasn't been powered up in, I don't know, probably 50 years or more. So I think we'll have to be a little bit cautious when we put power on it. Things that we're going to be looking out for is stuff like this rectifier here. I think I might actually try reforming this, although again I did bitch and moan and complain about reforming capacitors because it doesn't normally work. I think we might just have a go at reforming that one, see if it comes up. It may or may not. But before I do too much work on it, I guess I shouldn't make the same mistake as I did with that Evo signal generator, in that if I'm not careful we might actually find that there's something wrong with this mains transformer here, and if there is something wrong with this mains transformer, of course it's pretty much game over. So I guess before I waste any more time on this, I really should check that, shouldn't I? So let me go ahead and do that now. So we've got the meter set on the ohms range, and I've just clipped across these 2 pins. Now of course, if this was a 3-pin plug, we'd have to check that the fuse hadn't blown, but this hasn't got a fuse in the plug, so we've just gone off the 2 connectors. Now I am going to have to go ahead and replace this mains lead because it's only a 2-core lead, but I actually want to put a 3-core mains lead on. So we've got well, it's not 0 ohms, it's reading infinity at the moment. So what we actually need to do is we need to make sure the thing is switched on, and I would expect it's anywhere between I don't know, maybe 50 and a few hundred ohms. Not exactly sure, let's find out. Okay, so we've got 46.1 ohms. That's in the ballpark. That's probably slightly lower than I would have expected, but I'm not going to panic at this time. Certainly it's not open circuit, so that's a good sign, isn't it? So having established that the primary of our transformer is not open circuit, we need to actually check the two secondary windings. So what we've actually got here, we've got a HT, a high tension winding, which is centre tapped to the rectifier valve, and we're also going to have a couple of supplies which supply all the filaments to the valves. I'm guessing that this might be 6 volts, I'm not sure what it is. Let me just check what this bulb says on it, because typically whatever the bulb says on it is going to be the heater supply, which is a 6.5, so it looks like we're going to have 6 volt heaters on this. Now I've got to admit, I'm not exactly sure what is the winding arrangement on this transformer. I'm really not sure, so there's going to be a little bit of trial and error, but what I would expect is that we're going to have effectively 2 separate windings. We're going to have the HT winding, which is centre tapped, and we're also going to have the heating for the filament for the valve heaters, and they should be separated. Well, that's not a good sign. That seemed to be open circuit there. Oh, maybe not, just a bit dirty, the connections. Right, 124 ohms. $233, so it looks like black is the centre tap, so let me go to the centre tap, 115. 120. Boo! Well, I thought that I'd just interrupt the video because I wanted to talk a little bit more about this resistance measurement that we've just taken of our centre tap transformer. Now, some of you may have keenly spotted that the 2 resistance measurements that we took a resistance measurement for one half of the centre tap, and then we took a resistance measurement for the other half of the centre tap. Now, some of you may have noticed that those resistance measurements were different. Well, there's a reason for that. Although the actual number of windings is the same, the length of wire in each half of the centre tap isn't the same. So actually you will use less wire to actually wind the first half of the centre tap onto the transformer than the second half, because the second half of windings has to go on top of the first half, and the transformer will have grown a little bit in diameter, so it takes more wire to actually put each turn on. So you will actually find that if you actually measure the resistance of a centre tap transformer, don't expect the readings to be the same. They will actually be a little bit different, and that's totally normal, so don't worry about it. So that's the high tension side of the primary, or for those Americans watching, that's my B plus sorted out. Let's just have a look at these filament heater supplies now. Now we're going to actually get a much lower resistance reading, and the reason we're going to get a lower resistance reading for the valve heaters than the windings for the HT is because the valve heaters take a lot more current and the voltage is lower, so there's less windings and they're thicker windings, so we'll probably get less than an ohm for here. So let's just check that one. I kind of expect anything up to about 3 ohms. Okay, we're getting a reading of 0.5 ohms there, so again, we're in the ballpark, that's typical. So just based on those resistance measurements, I think I have some confidence that the mains transformer, it does look okay at this stage. We've certainly got no windings that are actually open circuit. So I think I'd like to actually go ahead and put some power onto this thing now. But before I do that, we've actually just got this 2-core mains lead, so we've got no earth on this chassis. And I think what I would like to do is, I'd like to replace this with a 3-core cable, so I need to put an earth on it, and once we've earthed the chassis we can actually do an insulation resistance test. So I'm going to go ahead now, I'm just going to put a temporary cable on to do some testing. I can't get at the nut that holds that cord retention grip on it because it's actually trapped behind this potentiometer, so I'm going to do things slightly out of sequence. Let's take this potentiometer off. Here, we'll take that out. That'll give us access to the cord grip. And while we've got this taken out, I think we'll just remove the cover and spray some switch cleaner into it. So let's get that done. So as per normal, to get access to the inside of this potentiometer, we've got quite a few of these little tabs on it that we've got to fold over, because it's actually kind of sealed this. Normally there's a little gap here at one end, where you could actually put the straw from the cleaning fluid in and give it a squirt. But unfortunately we can't do that on this occasion, so it actually just basically involves me probably stabbing myself and swearing a lot, so let's see how that will go. Okay, so we're going to need something small and pointy to try and get in under there. So I've got an old scalpel, so that's probably going to end up, blade's going to end up breaking off and stabbing me in the eyeball, no doubt. Come on. Okay, there's one opened up a bit. And again, for some reason, definitely the phantom pot twiddler's been in here, because this control, this rear stack control, stroke potentiometer, yeah, potentiometer, okay, whatever. It's also got the wiper set to just one end. And, every one of these pots has had the wiper set to one end, so I think the the phantom pot twiddler's been in here, and yeah, because there's nothing adjusted correctly, so we actually are after going to go back into here and adjust this. So just looking at the cap that I removed from this potentiometer, I think it says something like, well, unfortunately part of the name has rubbed off it. It looks like something like Mossonite, and not unsurprisingly it is also made in England. What value is it? Oh yeah, it's 2 megohms. Mossonite. Such was the day when everything was made in England. Okay, let's go for a little bit of a squirty squirt. Okay, well I've given that a squirt and a clean, so that should be okay now. Let's put the cap back on it. Snippy, snippy, snip, snip! Snip. So I'm just going to go ahead and just disconnecting the old wires that were on the mains input wiring. Now, I was talking to Simon Spears the other day, and we were talking about these tagged strips, and he was having problems working on a valve amplifier because he couldn't get some of the old wires, some of the old resistors that were stuck on the tag strip, because they can be quite annoying to do. And the way that I do it is I have an old pair of side cutters like this, and quite often what you actually need to do is you need to heat up the joint, and while the solder is soft you need to be able to get the side cutters in and cut off the old wire, and you want to try to cut it off as close as possible to the old existing tag strip, and usually the wires will just come out of it then. Basically, like I did there, but you want to use an old pair of side cutters, one that you're not bothered about damaging. And whenever I'm working on old valve equipment, I'm a great believer in a little bit of liquid flux, because when you're working on old tag strips like this, it really helps just remove all the oxidisation, and crud just helps cut through it. So you can see here that I'm fitting a 3-core cable, so we've got an earth wire, and I've got to actually fit this earth wire to some fixing on the chassis. Now the correct way to do it is actually drill a new hole so that you use a unique fastening for the earth lead. You shouldn't really use something like a bracket or like that, because somebody can remove the screw from the back bracket and suddenly your piece of equipment has been left unearthed. But unfortunately it's difficult to find somewhere to actually drill a new hole to install an earth bolt, and also I don't want to risk damaging something in that process if you slip with a drill, so I am actually going to reuse one of these fixing bolts if I can actually find one. There's one down there that looks as though we could use it, because that's the one that's fixing the kind of earthing the transformer frame, so that would possibly be one that we could use there. But it's not always a good idea to earth signal generators like this, because what you can do, you can introduce ground loops and things which can cause problems. But from the point of view of electrical safety, I think I would rather have a piece of equipment that's earthed. If it doesn't work correctly with the earth connected, I will consider removing it. But to be honest, if it is possible to earth a piece of equipment, you should always do that, because, you know, that's the safest way. That's what you should do. So as per our usual good practice, I'm actually going to install a crimp on this earth lead, and we're going to fit it here on the chassis, but we're actually going to leave the earth wire pretty long. Reason being, if this mains cord gets yanked out, we actually want the live and the neutral to get disconnected before the earth, so we don't want the earth to pull out first, which could potentially leave us with a live wire touching the chassis. So there you go, several hours later we've installed our mains lead. Now you can see that, interestingly, they've actually fused the live and neutral, so that kind of does indicate that this piece of equipment is designed to be powered up off that 2-pin plug, and because that 2-pin plug isn't polarised, it could actually be installed either way around. So they've double fused it. They've put a fuse in the live line and also one in the neutral, so this is the main supply coming into the piece of equipment. And then we've got these two capacitors here, which these are EMI capacitors. So I think I might have mentioned earlier, the function of these is actually just to stop RF radiation leaking out of the main flex and causing problems. But one thing you can almost guarantee is that these tend to explode even on modern equipment and go short circuit, and we certainly don't want these horrible waxy things to risk going short circuit and maybe starting a fire or something. Now when you replace them, it's important that you don't just use any old capacitor, because you have to use what they call safety capacitors, and there's actually two types of capacitor. Now one type of capacitor is designed to be connected between live and neutral, and they call them across the mains. And the way you can remember them is that the capacitors that are designed to be connected across the mains are what they call X-rated, and an X-rated capacitor is a bit like a cross, isn't it? So you can remember X-rated capacitors are designed to be installed across the mains. Now Y-rated capacitors are designed to be installed between the live conductor and the earth, so they're Y-rated. But quite often for these modern capacitors you can buy what they call XY rated, and that's what I recommend that you look for. Look for capacitors which are XY rated. They're designed to be connected either across the mains or between the live conductor and ground. Don't just use any old capacitor, because the problem with using any old capacitor is they could go short circuit, and if they do, they're going to blow a fuse, or even worse, they could even start a fire or something. So it's important that when you're connecting capacitors across the mains, you use the right type. So I've just gone ahead and had a look through my hoard, and I've actually managed to find some 220 picofarad 400 volt rated capacitors, and the most important thing is that they are XY rated, which these are. And I bought these from RS Components. Snippy snippy snip snip, snip snip snip, snip, snippy snippy snip snip, snip, snip. So what I've done is I've actually cut the leads on the capacitor relatively short, so that the actual long leg that I've left on it, the long leg is going to go to the ground connection, so that should always be earthy. It just makes a little bit of a smaller contact area for me to put my hand onto and, you know, risk getting an electric shock. But, you know, there's plenty of other things on here, including the hole of the fuse holder, where we can get an electric shock if we're really, you know, determined to. Well, I'm afraid it's now several hours later, and all I've got to show for it is 2 RFI capacitors installed. Oh well, sometimes that's the way it goes, these little jobs, isn't it? So what I'm going to do next is I think I'm about ready to put some power on this, and I mentioned earlier that we've actually got, let's turn it over, we've got a centre tap transformer. which is using a full wave rectifier. So again, a little bit of advice when you're dealing with valve equipment. What we're going to do is we're going to power this up, and we're going to have a look at all the output voltages from the transformer. But it's particularly important when you're dealing with a full wave rectifier in this centre tapped arrangement. What you want to do is you want to check each side. You want to measure the voltage on each side of the centre tap, and really they should be very, very similar. If you get you know, more than a few volts of difference, it's quite likely you've got maybe a shorted winding or maybe a problem. So you're expecting, when we do that test, we're going to find each of the voltage measurements on each half of the centre tap. They should be pretty much the same. So as you can see here, I've gone ahead and I've set up the old valve radio restorer's favourite, which is our lamp limiter. So I'm not going to run this thing up off a variac transformer because we haven't got the rectifier valve installed at the moment, so we don't have to worry about any DC on the electrolytic, because I probably need reforming, but not going to worry about that because we've got no rectifier. So we've got the lamp limiter set to low, power's on, so all we're going to do is let's switch it on. Hopefully this bulb won't glow too brightly. In fact, it doesn't glow at all, but we can see our transformer is clearly working because we've got light. Let's just check the on and off switch. So that's good, isn't it? So we've at least got, we can see we've got our heater supplies because our 6.5 volt, 6.3 volt bulb was lit up. Let me just turn that off, and let's have a look at the secondary voltages. So let me go ahead and check our centre tap voltages. So let's just check the first half of the centre tap. We've got 181 volts on the first half and 181 volts on the second half. So that means that there's no shorted turns or anything like that. So that the high HT, the high voltage output on this transformer is good. Now we already know that the filament voltage, which is going to drive our valve heaters, we know that that's good because this lamp is lit up. But let's just go and check it anyway. Okay, about 7 volts. Probably a little bit higher. It'll probably drop down when we put the rest of the valves in and put a little bit more load on it. But 7 volts, that's absolutely fine. So let's switch that off now and unplug. So the next thing we've got to decide how to deal with is this main electrolytic smoothing capacitor. Now I think I may have said earlier that I was planning on reforming this, but not so sure now. I actually think that maybe the best thing to do, just for time and expediency, is just pull this out. What we might do is I could go ahead and restuff it using the old can. Always a little bit of a debate that. I know some of you do restorations, you like to remove the original capacitor from inside the metal cans and replace them so everything looks absolutely original. I have done that in the past. Sometimes I do it, sometimes I don't. I've got to admit, when it comes to restoring equipment, I'm more interested in it working well than being, you know, cosmetically nice. But of course, it's a good idea if you can do both, you do. So what we'll do is we'll move this capacitor, and I think I will just put a new one in, and then maybe we'll come back and restuff that later if the rest of this signal generator works. You know, I think this thing must have been assembled in a very particular way, because half the screws you can't quite get at. Like there's some screws here on this elevated tag strip, and you can't get a screwdriver. You can get one into there, but you can't get one on there. And the same with this. There's a screw holding this capacitor in, and you just can't get at it. You can get about, you know, you can get about half of it on. Well, bugger me with a fish slicer. I haven't seen that before. So we've got this Hunt's electrolytic capacitor, and again, British made, and it says here red end 32 microfarads, yellow end 32 microfarads, can negative. So I've quite often seen these capacitors that have got, you know, more than one element in them. You can get one can and it's got 2 or 3 different capacitors in it. But whenever I've actually seen them like that, what they've actually done is they've had a third leg on them. But this one, it hasn't got a third leg. It's actually saying that the can is the return, and the return is just relying on this this bracket. So you know what, I don't like that. I think that's a little bit how you doing. I'd be much happier if this had a, you know, a properly mounted earth tag on it, not relying on this clamp. And certainly it means that when we put the new capacitor back on, well, we don't want it relying on the contact between the metal body and this clamp assembly, do we? That's really how you're doing. You know what, I think I might just check the circuit diagram to see if I am actually reading this right. So it looks like we definitely have got two capacitive elements in the same can. We've got C3 and also C4. So we've got some LC smoothing going on here, because you can see we've got a choke and then we've got C3 on one side and C3 on the other. So yeah, we've got some LC smoothing. Snippy, snippy, snip, snip. And here we go again, snippy, snippy, snip, snip. So here's the electrolytic capacitor that I've just removed, and of course it's a Hunt's capacitor, which will strike fear into any British radio restorer. And again, it's British made, and it says red 32 microfarad, 250 volts DC, reservoir yellow 32 50 volt DC, can negative. So there you go, can negative. Well, I'm not sure what you would do, but I'm definitely not going to rely on the body of a capacitor for the grounding. It's probably one of the most important parts of a valve radio, or in this case a signal generator, is a smoothing capacitor, and it's vitally important that you have a really solid earth, and especially something like this, which is effectively quite a high frequency transmitter. You want all the grounding to be done as well as possible, so no, I'm not going to rely on the strap around it. We'll have to do something better, and that probably means we're going to install some kind of an earth tag on the chassis. Right, so this is measuring 53.48 microfarad, so it's gone high in value. That might still be within a 20-30% tolerance, I'm not sure, but certainly it's much higher than 32. It's kind of nearly double, isn't it? The actual ESR value seems pretty low. It's 0.18 ohms, so 0.18 ohms, I would have thought that's quite a good ESR for this. Let's just check the other half of the capacitor, see if that's equally good. Again, it's gone high in value, so that's 45.6.2 microfarads, and the ESR is a little bit higher, it's 0.028. Now, this capacitor kind of looks okay at first glance, and at the end of the day maybe it is okay. It's hard to tell, because what we would need to do on this is a leakage test, but unfortunately I haven't really got any equipment set up to do a leakage test, but I expect it's bad. Anything that's coming up to 70 years old as this is, it's going to probably need replacing. So as you can see, I've removed the old capacitor, which actually seemed to measure okay, but I've actually replaced it with two modern capacitors, and what I've actually done is I've actually wrapped them both in Kapton tape and then bound them together, and I'm actually holding them just in the original clip. It's not a perfect solution. I think what I will do is, because it does look a little bit untidy, I'm not really that happy with it. I think that you can actually still buy some of the old style capacitors that have got, you know, two capacitors in one can. I was actually looking at some on earlier, but they are a little bit pricey. So if this thing actually turns out to be a worker and usable, what we'll do is I'll go ahead and I'll buy one of those nice capacitors, and we'll put it in, and that'll look a bit more original then. But I think for the purpose of the testing that we've got to do, I think this is going to certainly be good enough for now. But the thing about this original capacitor, it says can negative, and the actual grounding for the capacitor is through the can, and it was through this clip here. So unfortunately, although I've got a ground wire here, it's just kind of flapping in the breeze at the moment. So I've actually got to connect this ground to something, and I think what I'm going to do is I'm going to undo this valve base seat here. I'm going to remove this and put a crimp on it, and we're just going to, I don't know if we'll crimp it or solder it on. We're going to connect it down to there anyway. That's what I'm going to do. Now I'm sure you can see we've actually got quite a few capacitors in here, and it's these little kind of, they look as though they're made out of ceramics, and they are Hunt's brand. And again, quite famous for going bad. They quite often break open, they actually just break apart. Now if this was a traditional valve radio, a lot of the coupling capacitors that, you know, pass the audio signal from one stage of the amplifier to the next, they'll be physically quite large waxy capacitors. Well, we haven't got large waxy capacitors in here, and the reason we haven't got large ones is because of the frequency this piece of equipment works at. So if you're working at audio frequencies, it's a low frequency, you need large values of capacitance to actually pass the audio signal. But if you're working at VHF, or in fact UHF frequencies, you can actually use very high value coupling capacitors, and that's why we've got things here like, 33 picofarads and stuff like that. So we're not actually seeing any, big waxes in here. Hopefully you can see at the back here, we've also got some flat capacitors. Now these are mica capacitors, and again, they're actually relatively low value in capacitance. But the thing about mica capacitors, generally they are reliable. They're not, although they are a bit waxy looking, they're not the paper wax ones that causes all the problems. These mica ones will probably be okay. In fact, the capacitors that I took out, the RFI capacitors that I cut out and replaced, they were also mica capacitors. It was just the fact that they were wide across the mains. They were these X-rated capacitors. That's why I wanted to renew them rather than relying on a 70-year-old capacitor for safety. Well, it looks like we've been beaten by the clock again, and I'm sorry to say that's probably because I spend far too much time waffling on and not enough time actually doing anything. So I'm sorry about that. So it looks like you're all going to have to come back, or I hope you come back at least, to actually see this pattern generator in operation. So I hope to see you again very soon in part 3. But for today, I think that'll do. Bye bye for now. Bye.
And that brings the time to 13 minutes to 4. And from BBC One, good night and good morning.